Good afternoon. Today we are adding and subtracting mixed numbers, and we're going to answer the question, how does adding and subtracting mixed numbers change if I've got unlike denominators? Well, that's a good question. And the short answer is, not much. Let's take a look at a problem from last year. Here we've got 2 and an eighth plus 4 and 5/8. And just like when I'm using not mixed fractions or just plain old fractions, the first question I'm going to ask myself is, are the denominators alike or unlike? And right now, they're looking like they are like. I see eighths as the denominator for both of them. So easy peasy, I can just go ahead and go. I personally like to rewrite my problems so that they're up and down or vertical. And there we go. So I'm ready to start here. 1/8 plus 5/8 gives me 6/8. And 2 plus 4 is 6. Bam! Now, the last question I need to ask myself is, can this fraction be simplified? And if you take a look, they're both even, so certainly I can. If I can't divide them by any other number, I can certainly divide them by 2. And I'm going to go ahead and save you some time and tell you that 2 is, in fact, the greatest common factor for both of these. So 6 divided by 2 is 3. 8 divided by 2 is 4. So my final answer is going to be 6 and 3/4. You did this before. This is not a new skill for you. But what is this. What if I'm looking at a pair of fractions that have different denominators? Well, there's where the one change comes in. You got to find a common denominator, so it throws in an extra step. So the first thing I need to do is find my least common multiple for 3 and for 5. So here I've made my list of multiples, or count bys, because that's really all multiples are. And as I was writing, I came across one is the same here. Oh, I'm having pen trouble. Okay, there we go. So I see 15 on this list, and I see 15 on this list. So we'll need to change both of these fractions to 15ths. Not hard to do at all. So let's change 2/5 into 15ths. 15 divided by 5 is 3. So we're going to multiply by 3, do it to the bottom, got to do it to the top. 2 times 3 is 6. So 2/5 is the same as 6/15. I'm going to make a note of that so it doesn't get lost in all of the numbers on my page. All right, let's change 1/3 to 15ths. 15 divided by 3 is 5. So we'll need to multiply by 5, do it to the bottom, got to do it to the top, because this is the same as one whole. 1 times 5 is 5. So for practical purposes, I now have a new problem to work, and I'm going to rewrite it just because when there's so many numbers on a page, things can start to swim, and it's better just to keep everything new and even. Okay, so there we go. It's the same problem, just with the converted or equivalent fractions instead of the original ones. So now it's time for me to go ahead and add this thing. So that's fairly simple now that we have like denominators. 6/15 plus 5/15 is going to give me 11/15, and 3 plus 1 is 4. So I end up with an answer of 4 and 11/15. Now I've got to ask the last question, can anything be simplified? Well, I'm looking at 11 and 15, and 11 is prime, so it can't be divided by anything, and 15 is not a multiple of 11, so 11/15 is already in lowest terms. 4 and 11/15 is going to be my final answer. Okay, so go to your notebook. This is one of the examples in your notebook, and it's going to be a little more difficult. We've got 5 and 2/3, and we're going to subtract 2 and 3/4. And of course, question number 1, are my denominators like or unlike? Well, they're unlike. So let's go through the process of finding a common denominator, which means I start with my multiples of 3 and 4. Now, if you know your times tables well, you probably already know what your common denominator is going to be, but for everybody else, I'm going to throw them in here. All right, so there are my multiples of 3 and 4, and if you look at the lists, you'll see that there is one in common right in the middle, and that's going to be 12. So there's 12. Whoops, there's 12. Okay, so we need to make equivalent fractions using 12 as a denominator. Okay, so I've got to change thirds to 12s. 12 divided by 3 is 4. So I'm going to multiply by 4. Do it to the bottom, do it to the top. 2 times 4 is 8. Okay, so 8/12 is my first fraction. Now, 12 divided by 4 is 3. Do it to the bottom, do it to the top. 3 times 3 is 9. So I'm working with 5 and 8/12. Take away 2 and 9/12. So let me rewrite that in vertical form and with the new fractions in them. There we go. And there's a problem. We are trying to take 9/12 out of 8/12, and that can't happen. So remember back last year when we started doing this same kind of work with like denominators, it's not going to change here. I need to borrow. So I'm going to take 1 out of here, make that 4. And now I've got this extra 1, which I'm going to break down into 12ths. Why? Well, because it saves me from changing denominators again. 12/12 is the same as 1. The 1 I just took out of this 5 is now here. Okay, and 8 plus 12 is 20. And the denominator doesn't change. So now rather than dealing with 5 and 8/12, I'm now dealing with 4 and 20/12, which I probably should rewrite again. There we go. That's a little bit neater to deal with. So now we're going to do 20/12 take away 9/12 is 11/12. And 4 minus 2 is 2. So I get an answer of 2 and 11/12. Well, let's ask the next question. Can 11/12 be simplified? Well, again, 11 is prime, and 12 is not a multiple of 11. So that's already in simplest form. And the last question we ask in any math problem is, does my answer look reasonable? And right now I think it does. My whole numbers got smaller, which is what's supposed to happen when you subtract, so that's a good thing. The other thing is that I've got a fraction that's very close to a whole, and that doesn't surprise me too much because these were only headed off by 1/12 before I did all the changing. So I'm thinking this is a reasonable answer. All right, one more. This one's in your notebook too. In this case, we've got 3 2/3 plus 1 1/2. Now, I'm betting you can look at thirds and halves and probably come up with a common denominator on your own. Well, 2 times 3 is 6, and because the numbers are small, I can probably get away with that. I can always choose a common denominator by multiplying one against the other. The problem may be down the road that I'm making myself extra work when I simplify. It's really just a matter of when do you want to do the work, up front or at the end of the problem. But because these numbers are small, I can say to myself, oh, well, 2 times 3 is 6. So let's go ahead and make our conversion so that we've got fractions with a like denominator. All right, so there I am set up for that. 6 divided by 3 is 2. Do it to the bottom, do it to the top. 3 times 2 is 6, 2 times 2 is 4. And 2/3 and 4/6 are equivalent. Next one is 1/2 to 6. Now some of you are going, come on now, half of 6 is 3. And you'd be right. But I'm going to go through the trouble anyway. Do it to the bottom, do it to the top. 1 times 3 is 3. And yes, you are right, 3/6 is another way of expressing 1/2. So let's rewrite this problem real quick and get it ready to solve. There we go. Okay, 4/6 plus 3/6. 4 plus 3 is 7. So there we've got our 7/6, and 3 plus 1 is 4. All right, let's ask that last question. Is there something that can be simplified? Well, we've got a little bit of a problem. In our fraction part of our mixed fraction, I now have an improper fraction. I've got 4 and 7/6, and you know perfectly well we can't leave fractions like that. So rather than borrow this time we're going to do some carrying. So I need to take my 7/6 and I need to turn that into a mixed fraction itself. So let's take 7 divided by 6, goes in once, 6, subtract, you get 1. All right, so 7/6 is the same as 1 and 1/6. But we also need to remember this 4 down here because it's part of our whole number. So what we really have is 4 plus 1 and 1/6. And that, of course, is going to give us 5 1/6 as a final answer. So today we answered the question, how does adding and subtracting mixed numbers change if I've got unlike denominators? It doesn't. You just have to do that extra step and make your unlike denominators into like denominators by finding an equivalent fraction. Have a good afternoon.